So, welcome back. We're now going to continue with the pre-flight procedures past the point where we've finished the FMC stuff, and we're going to go straight into doing the walk around. So, to do the walk around in the most quick way and the most lazy way, since we want to save time, of course there's going to be a tutorial in the future where we go a little bit more into detail what the walk around feature actually can do and what you need to check. But to do it quickly, we go to airplane, we go to walk around, and then we can just select check all, and there all items will be checked on each side, except for the hydraulic service, but we can check that manually as well. But with that, the walk around is technically complete, and we've technically checked everything without checking everything. That makes sense. Now we can actually get into checking all the different panels, all the different push buttons and switches and selectors, making sure they're in the correct positions, just so that we are ready for the before start items. So let's go ahead and start with the overhead. And there are a lot of things we need to check here, and the scan is always from left to right, from up to down. So each section here, you can see they're nicely divided, is what we're going to go for. So there are 4 sections. We're going to go from up to down for the first section, then move to the right section again from up to down, and so on and so forth. So we already selected the 80 euro on earlier. There's no off light. The on bat light is extinguished. The symmetry compensation push button is in the auto position and no fault lights or any lights that are abnormal. The primary flight computers are in the auto position and guarded, and no lights. The electrical panel, we want to make sure the APU is currently off, which is fine. We're going to start that again for fuel savings, for noise savings, and for CO2 savings. We're going to start this about 5 minutes prior to pushback. But the rest we need to turn on or auto. So the in-flight entertainment as well as the cabin utilities come on. The APU generator we can pre-arm to on, which is technically the auto state, and make sure that there are no lights. Bus ties and external powers we already checked earlier, make sure that there's no abnormal lights, for example isolation. And then we set all generators, the main generators as well as the backup generators, to on. They will not be running of course at this point, but as soon as the engines do run and the IDGs are spinning at a sufficient rate, they will automatically connect and supply us with power. The drive lights are normal as well, since the IDGs don't have sufficient speed. Up here we already set our voice recorder to on. This is selected off, that's checked. The ELT is guarded and armed. The emergency lights are guarded and armed. Service interphone would normally be in the off position, but we do require it for ground communication with our ground personnel. Passenger oxygen, make sure that's guarded and no passenger on light is illuminated. We'll make sure it is extinguished. We turn on the window heats, verify that the in-out lights are extinguished. Then the ram air turbine, we want to verify it's guarded and we don't see any lights, make sure it's all extinguished. And then the hydraulic panels, we will set the engine driven primary pumps to on. The rest stays off for now. For the seatbelt signs, we're going to set no electronics to auto, and the seatbelt signs will leave off if we're still refueling, and if we're not refueling, we're going to turn them on. For now, we're still refueling, so I'm going to keep them in off. Lights as required and the exterior landing lights should all be off. Going up here to the cargo fire, the fire test itself is something you can do. It is optional, some airlines even do it. However, it is normally a maintenance function and is not part of the normal operate or normal procedures. We're just checking that the APU handle is in, that there are no abnormal lights, that the arm switches are extinguished and out, as well as the discharge bottles are not discharged and no lights. For the EECs, we want to verify that they are in the norm position and that there is no alternate lights illuminating. For the start ignition switches, make sure they are in normal and that the auto start switch is selected on without a light. Fuel jettison, we're verifying that all the push buttons are out, there are no lights, and that the system isn't armed. For the fuel, verify that all press lights are normal, which they are. If the APU was running at this point, you would most likely see the left forward aft pump press light extinguished, which is normal. But in this case, we want to keep all fuel pumps off, which is checked, and the cross feeds should also be off. Anti-ice should be selected to auto and is kept in auto for the most of the flight. It is very rarely set in on and pretty much never set to off unless the system is faulty or anything else requires it. Exterior lights, again, nav lights as standard, the rest can stay off. Logo light is as desired, as well as wing light if the inspection requires to check for icing or anything like that. But nav light is definitely the must here. And I'm going to set my indicator lights to bright. Next we're going to go up here, we're going to set our forward cargo AC as we desire. The humid push button we're going to go ahead and select on. Gasper fans we're going to select on, verify the equipment cooling is auto and that there are no abnormal lights as well. For the recirculation fans, upper and lower, now this again depends. We currently have the air conditioning carts connected. They are supplying us with air in the cabin and cockpit, and it is required, again, as we've mentioned before, to have these as well as the pack switches in the off position while the air conditioning cart is supplying us with air. So we're going to keep these off, otherwise select them to on or auto, same thing with the packs, but for now we're going to keep them in the off position. Flight deck temperature as well as cabin temperature select as desired, usually the 12 o'clock positions or the auto positions. Trim air on and verify the fault lights extinguish. The bleed air isolation valves all set to auto, verify that the closed lights extinguish. The engine bleed push buttons all in the on position and verify that the off light is still illuminated. This is normal since the engines aren't running and can't supply us with any air. And the APU push button, APU bleed push button in auto position and verify the off light extinguishes. Pressurization, verify that the forward and aft outflow valve switches are in the auto position and that there's no abnormal lights. Make sure these are in the middle position. These should be spring loaded, so they should always be in the middle position. And that this is pushed in. And the wipers, of course, are off. So now we're going back into territory that splits us apart a little bit. We need to differentiate between the first officer scans and the captain scans because, of course, each have their own side to deal with. And in this case, I always like to start with the first officer side, make sure that is done, and then we're going to continue with the captain side and finish off with the captain side. So let's go ahead and get started with that. The first thing we're going to do is we're going to select our flight director to the on position. And then we're going to skip to the EFIS control panel and set anything we desire here. Now there are a couple of options. Of course, you want to set your range as desired. Usually it is set to the lowest option that displays your first waypoint on the navigation display. But I always like to do it a little bit higher for the first officer so that since I normally sit on the left side in the flight sim and I want to have different viewpoints, I sometimes set this higher or at a different rate at what I would do on my primary display. So my primary navigation display. So I set this normally to 20. Make sure the traffic is armed. You will notice when the TCAS off indication appears. So if I were to select traffic, you can see it's now no longer armed. To make sure that's armed, set the VOR/ADF selectors as desired, usually in the VOR position. And these are required especially if you had to insert any NavRad information in the FMC earlier. Airport and data is pretty standard, and for the pilot monitoring, terrain is also pretty standard to set, which we can do already. Now, we are in Europe, which means we use hectopascal, so we're going to go ahead and switch that over. So we're now at 1013, and we would set our current altimeter. Typically speaking, we would have either an ATIS, or we would have a weather set here, or we can also listen to ATIS via the RMPs. The QNH is approximately 1015 today, or 1016. We'll set that. And then for the minimums, now this is also airline dependent or pilot dependent. Every airline kind of defines this a little bit differently. What I like to do is I like to insert my my return runway minimums. So we have earlier in the FMC tutorial planned to return to Frankfurt on runway 25 left in case that was ever needed. And so what I would do is I would open up my charts for that ILS approach and insert my minimums here, which we can go ahead and do for demonstration purposes. So I'm going to go to EFB, show EFB1. We're going to go to the charts, and we're going to go to the ILS runway 25 left that I've clipped, and we can see that the minimums for the ILS, because it's the CAT 2-1, I don't think we'll need that. Just regular ILS. We can see that our minimums in Barrow is 561. That's exactly what I'm going to set here. So we're in Barrow. I'm going to set 561. And so in case we ever need to return, this is already pre-selected for us, and we don't need to waste our time and effort looking around for this. Then FPV meters as required. Meters usually used in the areas where meters is our normal altitude readout. So for example, China, but we don't require it at all for this flight. And just want to verify that weather is off for sure. Then we move to the right and we go through the lateral consoles, and we start from right to left, and we move around here and then move down to the pedestal. So normally that starts with the oxygen test, which you can also take out if you want, but something you shouldn't do. And we want to verify that this is set to the 100% mode, and we can do an oxygen test. Okay. So yeah, you would normally test the oxygen and test the speaker as well, and this is also something you would normally ask ground personnel whether they're clear of the headset, because this can be relatively deafening. It's really loud. And the way to do that with the mic check is something we can only do on our own ACP. Just as a reminder, there is an option when you start the airplane at first, you can choose whether you're going to be the captain or the first officer, and that also changes which ACP is being used as a primary. So we're going to skip we did the oxygen test, that's fine, but we're going to do it the proper way on the captain's flow once we get there. Just check that everything else here is set as desired, make sure all the lights are set, the heaters if you needed them are set, and important is verifying that the navigation source select panel, that all these push buttons are in the off positions, so nothing is selected. Verify our UTC time, and we can also verify our dates by pushing on this push button, and it will cycle through the year 2026 and usually the date as well, which is 1103, which is checked. So that is all working correctly. Make sure that anything that was done here, whether chronometer or the elapsed time, is reset, so this is blank. We're going to check our PFD. We verify that toga is armed, that we're in flight director mode, and that our only flag is our no V-speed flags, which is checked. We go to the navigation display. Again, we're checking for no flags, nothing abnormal besides the TCAS off flag. This is checked. Verify that the inboard display system is set to MFD. The FMC course is selected to auto, and we check the ground proximity panel, verify that nothing is illuminated here, nothing is selected on, that the alternate gear is in the normal position and guarded, and the auto brake selector is set to RTO. Then what we check are the ICAS and MFD displays. So we want to verify that the engine indications here are proper and correct as we expect. Verify the indications here are also correct as well. We're going to check the status indications here, or the memos, in a moment. That will be the captain's thing. And then we're going to go to the engine secondary display, so the MFD, and verify that also here the indications are correct. There's no amber X's or anything that doesn't make sense, which is checked. Go back to the status page, verify that we don't have any status messages that we need to deal with. If there aren't, that means the airplane is in a perfect working condition. You then go to
checklist. Oxygen tested 100%.
Which is something we don't want to trigger like that. What we actually want to do is we want to go to resets, verify that the database is up to date, and then select reset all. We then go to COM, we go to manager, we go to the master, and if we needed to reset anything, we could do so via there. And then we go to system information and verify that our information here is checked. Then we go down here to the center pedestal, and we want to verify that the RMPs are all selected on as required, and that the frequencies are set as desired as well. So for VHF 1, we're going to select anything that we are using actively. So for example, on VATSIM, you would use 1 to 2.8, or you could put in your ATIS, your delivery, ground, so on and so forth. On VHF right, we're going to set our guard frequency of 1 to 1.5. Then we skip the ACP because the first officer does not care about this. This is of course the option of the captain, so we're going to skip this and we're going to go to the weather radar panel and we're just going to set weather plus turbulence here, make sure we're in auto mode, and that's pretty much all we're going to set. We could change the gains, but we don't really need to. We can keep them in the 12 o'clock positions. VHF center, verify that data is selected for ACARS, and normally you would not set anything here on the observers. ACP, unless we had an observer who would want to listen in as well. So we can keep this off. The flight deck door set to auto and no abnormal lights. Then we also want to verify that the engine fire handles here are pushed in, that nothing is discharged and no abnormal lights. Make sure the rudder trim is neutral. Aileron trim should also be neutral, which we check here with our yokes, which they are, so they're in 0. And then we can set up our ACP as we desire for the first officer, which I'm fine with here. I really only care about this one, which we'll do once we get there. So I'm going to go and just set this to 0 for now. Our TCAS panel, so our transponder, we're going to set as default for 2000 for now. I'm going to set above for both displays at the moment. We're going to verify that we're in alt source norm, and then the transponder we use is selected to the side of the pilot flying. Since the captain, we are the captain and the pilot flying, we're going to select system left. If the first officer was the pilot flying, we set system right. Go down here, make sure that the evac guard is guarded, no abnormal lights, no horn to be heard, and that the observer audio is set to normal and the lights as required. Now some additional items we can check and simulate and do would be, for example, a high frequency check. And the other thing, which is not simulated but something that might come in the future, is the cell call check. These two items we would not do if fueling was still underway for safety reasons. However, I'm confident that we can do them now since fueling is completed. So let's do a high frequency check, and we can do this by going to high frequency, either left or right, doesn't matter. I'm going to select right. We can tune any high frequency that is standardized for UTC coordinate, so universal coordinate time or universal coordinated time, which for example is 10.0. So we can set that to active, and then we can select VHF right to hear, to listen, and set up the volume. And you can either listen to the tones, and also once in a while a voice can be heard giving you the exact time as well. If you wanted to check any other channel that you think you would use, for example for North Atlantic tracks, we could insert that as well and just verify that we can hear some kind of static noise, which we do. So that means the high frequency works. We can check the same for left. So if we go here and we insert a frequency, we can check the static there as well. Now we are going to do the captain's flow, so the CM1 scan, and we're also going to start with the EFS and work our way around from left to right, and then again do the lateral console check from left to right and going down here. We have a little bit less to check here, but more importantly we have the autopilot to check as well. So let's go ahead and start. So again, doing the same checks, we're verifying that our QNH is set properly, which has now changed back to 1013. So that is set, and it is in hectopascals. Then we're going to set our minimums here as well. If you are wondering what other options there are, what other airlines possibly do, is they sometimes, especially in the 737 NG, they've done this or do this, is they've insert the thrust reduction altitude as their minimums. It really doesn't make sense here to do because we have VNAV to do that, and this airplane is very well automated. But back in the day, it certainly could have made sense for something like the 737 Classic to do this with. I would still continue setting the minimums for my return runway, which is 561, and insert that here as well. I'm going to select flight path vector on my side as well. VOR, VOR. Verify traffic is armed, which it is, set 10, or the lowest range I can set where my first waypoint is visible. and set airport and data here. I'm going to leave terrain off because we're going to later select weather. Not now, not on the gate, but we'll keep it blank for now. Flight director is on our side as well, and the auto throttle left and right should be armed as well. Then we go over to the MCP. We're going to leave our speed at 200 knots for now, and what we can set is a runway track of 176. Now some airlines keep it in heading mode, some airlines use track for the initial departure. Just keep in mind, whatever you use, make sure that once you are vectored by ATC, that you go back to heading mode. The reason I like to use track for the departure itself is that it compensates for when we have an engine failure. So what if I were to go to heading mode, I would most likely go off track and not fly a straight line, whereas with track it should compensate for that and it should fly the perfect track along. So in case of an engine out, this is why I use track, and I put in my runway track of 176. But again, keep in mind that you must switch this back to heading mode as soon as you're dealing with ATC vectors and stuff like that. Let's set the vertical speed is checked. The altitude I'm going to go and set into 1,000 increments, and I expect our initial climb to be 4,000 for our SID. And what I like to do is set plus 100 as a reminder that we still need to get IFR clearance from ATC, and so that is what I use for that reminder. Now this is also rather dependent on the pilot and the airline procedure. What I like to do as the last step on this panel here from the captain's side is verify all of our messages. So what I do is I click the cancel recall, make sure everything is cleared, and then recall it and verify that all messages are correct and as they are expected to be. In this case, I would say these are all normal, so I'm going to cancel them so that if anything ever pops up again, it should show up. And that makes everything look cleaner as well. Once that scan is complete, I continue with the left side again. And here we can now tune in order to test the microphone. So we're going to set the speaker, we're going to set it to all the way up. We need to be in the flight mode and verify that that is also set up. And again, we need to verify with ground personnel that they're ready for this, otherwise their ears are going to be blown off. We're going to set mic, and then make sure this is on 100%, and we'll do the test. And you can also, as you also heard it through the speaker, which is checked and working. If I were to go back to off, you would see don't hear it through the speaker anymore. That's what we're checking, and that is working as well. Wonderful. We'll continue here, verify everything is set, the brightnesses are all set, heaters are set. Make sure again at the instrument source select panel that all the push buttons are off and not selected. The UTC time is checked. Verify the date again, 26/11/03 is checked, and verify that the elapsed time / chronometer are reset, so blank. PFDs, toga is checked, flight director mode is checked, no V-speeds is normal. That's the only flag we can accept, and all the other indications are normal and as expected. So 0, we're looking for ground speed 0, make sure altitude is checked, and all that good stuff. For the navigation display, we're also checking, making sure that everything is looking as it should, and the only flag should be the TCAS off flag. Looking up here, we can see again the pressure is fine, and the brake source light is normal as we don't have any hydraulic pressure. The inboard display switch set to MFD, and the heading ref as required, but for our case we only require it in norm position, so norm. Standby instruments, this will depend on if you have the digital version, so the integrated standby flight display, or if you have these older versions. And here you would also verify that the altimeters are set, make sure there are no flags, and that all the indications are what we expect. So pretty much dead center here, speed should be no higher than 30, and our QNH again is set with the proper altimeters. Then we go down here, and the last items we ourselves need to check is the throttle quadrant, make sure the speed brakes are in the down detent, the manual pitch trims are centered, the thrust levers are idle, the reversers are stowed, flaps are up, and the indication it does agree. There is no indication, so that's agreed. Fuel control switches are in the cutoff position. The stab trims are set to normal and guarded, and the trim is for now normal. And then we go down here and set up our ACP as we desire. So VHF left, VHF right, a flight cabin as well, speaker, and the rest is really as you require. Once both sides are complete, we can then continue with the pre-flight checklist. So let's open the checklist.
Pre-flight checklist, please. Oxygen, tested 100%.
It'll say oxygen tested 100%. I'll also say tested 100%.
Tested 100%. Flight instruments.
So flight instruments heading 2901, 2901, altimeters 1013 with 360 feet.
Set. Checklist complete.
And checklist complete, so we can go back to, for example, the status page. Once this is done, what I typically do is I go to my left inboard display and I set the door page, and then sometimes the FO sets the status page on his right side, which is not really required. We can set it down here. But I like to set my door page so I know that everything is, what else is open, what needs to be armed on this part right here. So once boarding and the entire airplane has completed loading, you will get the final load sheet, which starts off between the thrust levers. You'll also get a call from the purser telling you that boarding is completed. So we can move this around, and the best place to put it, I think, is here on the window, and we'll review that, of course, for inserting the final figures in the FMGC, or in this case it is the FMC. So let's go ahead and cover that part of the final figures that we need to insert. We've got our final load sheet, we know the fuel's on board and loaded. First thing we're going to do is make sure the seatbelt sign is on at this point. We are also, generally speaking, the load sheet comes around at the same time where we would require to request IFR clearance, so around 15 to 10 minutes prior to pushback or the off block time. So we would also request we would request IFR clearance, which means we would get our squawk code, we would get our initial climb, and also we would need to double check our standard instrument departure, which we can go to route page, next page, and verify if it's correct. If not, we would go to the departure and arrival page and update your departure page or your departure. But everything is checked out, so we have the proper SID set, we have our initial climb pre-selected, and our transponder is set. So with that, the IFR clearance is complete. You could also do this through data link, which is also a possibility. So with the final load sheet, what we're going to do is we're going to review the figures. So I'm going to try to get into view as best I can, and we're just checking that this is the correct flight number. It is, that we're in the correct airplane, and it is the correct flight from Frankfurt to Newark, which is checked. We have a total passenger count of 295 with a different no infants, so question mark infants, so apparently no infants, and we are these are the distributions, crew, and who the captain is, the first officer, and so on and so forth. So that all looks good. Cargo, we have 20 kilopounds, and we can see some details here as well. For us, important is down here, this section. We can see fuel on board is 150 kilopounds. Our takeoff fuel expected is 149. Our zero fuel weight is actually 383.7. Our takeoff weight is 533.0 approximately, and our Mach zero fuel weight is 27.6. For takeoff or gross weight, that would be 34.3. And then we have some other additional info down here. So what can we do, and what do we do with this information? Well, first off, we're going to go to the CDU and we're going to verify this information. We saw that our zero fuel weight is 383.7 now, so it has changed slightly. We can double check that, 383.7, perfect. And with that, we can expect a takeoff weight of about 533. So we're going to go to thrust limit, and we're going to open up our EFB and do some takeoff calculations. So we're going to go to performance, and we're going to insert again all the data we need if it wasn't already inserted. Or there's another method you can use. If it's completely blank, you can just select copy FMC data, and we'll fill out pretty much everything that you require. Runway 18 is still valid. runway condition dry at this point, and we insert our data. And the weather has changed. The wind is now 210 at 7. Outside air temperature, we're always going to use our active temperatures plus 1 degrees, which is 11. And our QNH is 1014 minus 1 is 1013. Our takeoff weight we said was 53300. And our takeoff CG, in fact, we can double check that again with the load sheet right here. So 533, and our CG is 34.3. Our thrust rating, what I typically do is I start with takeoff. Normally there are optimum options. Same thing for the flaps. Normally there are optimum options, but I always go with takeoff first, then flaps 5, and anti-ice we're going to keep off. We don't require that. And then I calculate. And the way you normally do this is you want to make sure you choose the takeoff rating with the lowest amount of EPR and the highest amount of takeoff weight. So we have an EPR 1.519er. Then we're going to go takeoff 1, 1.432, takeoff 2, 1.432 as well, but the takeoff 1 has a higher available max takeoff weight. We're going to go with takeoff 1, calculate, and we can see this has changed. So that's how we determine the takeoff rating, and you can typically do the same thing with the flaps. The one with the highest takeoff rating is the one that you want to use, but you want to go as little as possible. So flaps 5 is perfectly sufficient for today's flight, or takeoff, which is perfect. So we've done the calculations, and these are the values that we have. Flaps 5, runway 18 is checked, a trim of 3.75 is what we expect, and we can expect a D rate of takeoff 1 with an assumed temperature of 61 degrees. So let's go ahead and select takeoff 1 and 61 degrees. Now normally I have to double check this. We're going to go like so. We're going to go 61 degrees, and let's see if it changes. Yes, it does. It goes to climb 1. So we double check, is the EPR approximately the same as this? Yes. This will slightly change depending on the PAX configuration, so just keep that in mind, but they are relatively close. And we've inserted again takeoff 1 as we've calculated with an assumed temperature of 61 degrees. That is calculated here. Then we go to takeoff page, and we'll also insert all the data here. Flaps will be 5. The CG is 34.3, so we can put 34.3, and it will round it and gives us a trim of 3.75, which we can double check here. We're going to go to the next page, and we're going to insert any information we require here depending on airline configuration or anything like that. I'm going to set 11 degrees here. You can set in your wind data as well, so 210 at 7. This is all not required. What is required, however, is the acceleration and thrust reduction altitude. So if you're doing a noise abatement departure procedure, for example, either 1 or 2 or A or B, this is something you would need to reflect on, or if your company has special procedures, you would also have to reflect those here as well. Normally there's also an engine out acceleration altitude that you can insert, which is currently not available. I'm happy with 1,000 feet and 1,000 feet, which means at thrust reduction of 1,000 feet above the ground is when the thrust levers will go into the climb 1 detent, and the acceleration altitude is when we will start to pitch down to increase our speed to our next requested speed, either through a speed restriction or the 250 knots below 10,000, for example. So once that is set as we desire, we then insert our V speeds. The typical real world scenario is that you always take the EFB performance calculations and insert them over what has been calculated here. Depending on airline philosophy, they'll have certain tolerances. For example, with bigger airplanes, you can usually go by 2 knots difference. So if the difference is 2 knots or lower, you can also just quickly accept what is calculated here. For example, in this case, this is not the case here. 139 is more than 2 knots difference, so we're going to go with 139. Same thing with 142 for BR, and then same with V2 with 157. We are going to go with 147 as calculated. But once that is inserted, what we are going to do, we're pretty much done with the pre-flight of the FMC. We're going to set the V2 speed in our indicated airspeed on the MCP, so 147. And if LNAV and VNAV is used for the departure, which it is because it is an RNAV departure, we can arm and LNAV and VNAV as well. And we should see them in white armed here as well on the FMA. Now for some additional info that could be useful, if you wanted to check stop margins and things like that, you could also click show and you get some additional information. For example, how much distance until V1, how much until V2, the brake distance, and all that stuff that could be useful as well. And as well, what could be useful is when do I actually use an assumed temperature, when do I not, and how do I apply that here, which is relatively simple. You also need to consider, are you going to use a PAX off takeoff? Are you going to do an APU to PAX takeoff as well, which can all be reflected here. Normally there is another selection here where you can choose the pack configuration, which should also be applied to the calculation. So currently this is somewhat not possible with the calculation itself, but most likely in the future this option will be available where you can select the air conditioning as well. And these are more expert level things that we would cover in some other videos possibly. However, assumed temperatures cannot be used normally in contaminated runways like standing water, slush, or ice, and D rates are not normally used when there are warnings of wind shears, for example, but otherwise fixed D rates are always allowed as long as the stop margin is sufficient even in adverse weather. So that's how you can determine. If you don't want to use an assumed temperature, all you have to do is insert a temperature that is lower than our outside air temperature, so for example 0, and it will select our current temperature and then calculate. So it will say there's an assumed temperature of 10 degrees, but in reality that's just our outside air temperature, which means in the thrust limit page you would leave this blank. That's pretty much all there is to that. So I've just received a ding that some kind of ACARS messages came up, or somebody's trying to contact me, and indeed we have a CPDLC message. And we can also see the COM indication here, and look what it says. It is our fuel sample. It says our fuel sample test is complete. Our freezing point determined at -48 degrees. We can review this, and that we go into the COM page, we go to new messages, open up the page, and you can then see the message here in full. And if you remember in the FMC tutorial, there is indeed something where we can insert this, and we go to the performance init page, and you can see that the freezing point is -48. And what I said is the typical range that we use it is we add +4 so that we have some kind of margin between the actual freezing point and when we get a warning. So -48 plus 4 is it was +3, +3. So -48 plus 3 is -45, which means that at -45 degrees Celsius, when the fuel reaches that temperature, we're going to get a caution or a warning. And so that means we have a margin of 3 degrees to deal with. And that is what you would insert here. So we've now set up the FMC, we've also set up the MCP. Some last optional items that I normally check is go to progress page, verify our TARPA cruise is still within a good range, which it has increased a little bit because now it is taking into consideration our D rate, our V speeds, and all that stuff. And same thing with the fuel. So I just want to verify that this is still all valid, which it is, just a double check. And then usually the pilot flying has a takeoff ref page, and the pilot monitoring has normally the legs page open. We would also prepare for the departure briefing, so we would collect all data that we needed in order to do a proper briefing, and then do so as well. To use the simulated pre-flight briefing, we can go into the airplane page, the captain's commands, and we can read the pre-flight briefing. Now, usually you would also make sure that the door is closed at this point. You don't want any disturbances, and usually you don't expect any disturbances at this point anymore either. Anyways, but just to make sure you close the door, and then we could do the pre-flight briefing.
It is time for the departure briefing. Are you ready on your side? Yes, sir. The pre-flight procedures have been completed and instruments are set.
Alright, so that is the departure briefing. With that done, that means we are pretty much almost ready for pushback. What we're going to do now is we're just going to make sure our seat is adjusted, the rudder pedals are adjusted, seatbelts and shoulder harnesses are set as desired, and then we can welcome the passengers on board, which you can also do here via going to PA call, and selecting welcome.
Ladies and gentlemen, I, the captain, would like to welcome you on board this FlightFactor aircraft.
That is the welcome announcement. So, what I'm also going to do now is, now that we're about 5 minutes away from pushback and engine start off, so about 5 minutes away from the off block time, I'm going to go ahead and start the APU. Once the APU is running, which we can determine either through the percentage of the RPM or the ICAS APU running status message, as well as the secondary external power kicking off, we can then do some last minute items. We're going to select the primary external power switch to off, and the APU now has full control of our electrical system. We're going to go to the ground crew, we're going to call them.
How can I help you?
And we're going to request to disconnect all equipment.
Ground equipment is no longer needed. Please remove it.
As soon as possible.
And that should remove absolutely everything. Once that is done, what we're also going to do, since the air conditioning cart now is disconnected, we can apply the recirculation fans and the pack switches. Now we have some air conditioning. We will also call the cabin to close all doors.
Sir.
Please close the door.
Yes. Would you like something?
Please close this door.
Gladly.
So we're going to select all doors that we need to close. And we can verify that here on the indication. There's still one door open, that's the forward door access, that's by default open. Let's go and request to close all hatches.
Please make sure all hatches are closed and all personnel clear. We would like to pressurize the hydraulics.
All personnel is clear. You may pressurize.
There we go, the door is closed. We can also pressurize the hydraulics, which is the perfect segue to our before start procedures and tutorial. The last thing I'm going to quickly do is request the doors to go into automatic.
Yes, sir.
All doors to armed mode.
Aye, sir. All doors are in automatic position.
Which we can double check. There we go. And then we can recycle the switch from MFD to nav back to MFD, and that will clear and revert us back to the navigation display. So with that all complete, we are now pretty much ready for the before start items, which we'll cover in part 4.